string theory is?
Sure. The basic idea is pretty simple. If you take any object, for instance, the tabletop, and magnify it and examine it on very small scales, there'll be molecules and atoms. And if you look at the atoms and magnify them, you'll see that there's a nucleus, protons and neutrons, surrounded by orbiting electrons. And in 1968, we learned that if you magnify a proton, there's yet further substructure. The Russian dolls continue. Inside there are 3 quarks, even smaller particles. Now, for a long time, people thought quarks and electrons were all there was, together with a few other exotic particles that make up the universe. String theory comes along and says, actually, there's one more level of substructure. If you examine an electron or examine a quark at incredibly fine resolution, you'll find that there's a single loop of vibrating energy that we call a string. And that's the idea of string theory, that all of the particles in the universe are different ways in which a fundamental loop of energy can vibrate. So much like a violin string can play a C, it can play an A sharp, different notes that our ear senses, different tones, the different ways that these fundamental strings vibrate correspond to the different particles of nature. An electron is like a C, a quark is like an A sharp, and so forth.
We know that there are these 4 dimensions. We know that there's height, we know there's width, we know there is length, and we know there's time, right?
That's right.
There's the 4.
Right.
String theory brings 6 new dimensions.
Yeah, at least 6.
At least 6.
Maybe 7.
Maybe, okay. What are they?
Well, they're actually of a similar character to the ones that we're familiar with. They're just very tiny. And actually, I have a small prop that I like to use to describe this. So forget about the universe for a moment and let's just look at this piece of wire. Now, from very far away, this wire would look like it's one-dimensional. In that, for instance, if a little ant was living on it, you'd say, well, it can move left and right along the wire, but that's it. There's only one possibility. Yeah. But then as you get closer to the wire, you realize that there's a second curled up circular dimension, the circular girth of the wire. Right. And therefore, our microscopic ant can not only go back and forth, it can also walk around the wire, a second curled up dimension. And what this little example alerts us to is that dimensions come in 2 varieties. They can be obvious and long and easy to see, or they can be tiny and curled up and more difficult to detect, like the circular girth of the wire. Now, what the idea is, according to string theory, is that the fabric of the universe is much like this piece of wire, in that there are the familiar dimensions that you referred to, left, right, back, forth, up and down, and also time, but there can be additional dimensions that are tightly curled up, like the circular girth of the wire, and are so small that we haven't seen them yet, because we don't have sufficient magnifying instruments to actually peer down into the nooks and crannies of the spatial fabric and see these extra dimensions. But string theory says that they absolutely have to be there. There are at least 6, as you mentioned, and quite possibly 7 that are curled up into the fabric of the universe.
Is this such a hard idea to tackle that there may be 10 people doing it in the world, or is this something that there is every young physicist on every campus in America thinks that I'm going to find the answer to the riddle of unity in nature?
It's more like the latter. These ideas seem abstract at first, but when you do phrase them in the language of mathematics, you find that it's actually not that difficult to describe all these extra dimensions. And graduate students across the country are learning about string theory and doing research, some of it cutting-edge research on the theory.
How do you go about the investigation? Now, can I imagine you sitting in front of a computer doing thousands and thousands and thousands of equations?
That's close to it. Certain projects do require a computer to do the analysis. Other times it's really a pen and paper, and it's just manipulating symbols which describe these extra dimensions or which describe the strings.
Looking for what?
Well, what we're looking for is a coherence in the equations which will show us that we actually have a theory that is, number 1, self-consistent, and number 2, actually describes our world. It could be that you come upon a wonderful theory that describes gravity and quantum mechanics and all the things around us, but it misses. It's a near miss. Right. For instance, it might predict that the electron weighs 10 times what it actually does. If that's the case, you have to throw the theory out the window. That's right. So what a lot of us are doing is trying to extract observable physics from this theory and compare it with experiment. That's the goal, and we're a bit far from it, but that's what we're trying to do.
What a bummer would it be if you think you found it, and it tests well here, tests well here, tests well here, tests well, and then you get to like your 999th test to see if it fits. It doesn't fit.
Yeah, it would be quite a bummer. It'd be a real drag, but that's sort of what science is about. You know, you give it your best shot. Yeah.
Now, where are you in this?
the particular work that I do? What I tend to do is focus upon these extra dimensions. And I've been focusing on ways in which they can evolve that Einstein wouldn't have thought possible. It turns out that string theory says that space itself can tear apart and reconnect in a number of complicated ways that Einstein would have thought impossible based upon his pre-string theory understanding of the way the universe evolves. So that's my specialty.
Okay, now if I could get together in this room 10 of the smartest physicists in the world, would 9 out of the 10 believe that string theory will explain this one great equation that will explain all of nature?
Well, if you
9 out of 10.
Well, if you let me pick the 10, I could make it 10 out of 10, actually.
Well, just say 10 really smart ones. I mean, for example, 10 years ago, Stephen Hawking, if he was in the room, would not agree.
Yeah.
You know, are there still people that are not convinced that have the mental agility of Stephen Hawking?
Sure. There are a few, but it's really becoming a minority group that are the decriers of string theory. In the early 80s, when string theory made a big splash, there were many people who said, this is just a fad, it's just the beginning of something that's going to go away. But we're now in 1999, and 15 years of research and success has shown us that string theory is really part of mainstream theoretical physics. So yeah, I'd say 90% is a good guess.
All right, this is what they said. We became aware of you because of New York Magazine. They did a story a couple of weeks ago in which it's called He's Got the World on a String. String theory is the hottest development in physics since Stephen Hawking first peered into a black hole, and Columbia physicist Brian Greene is one of the few people who can explain it. He also acts in Pinter plays and packs lecture halls, and his new book, The Elegant Universe, is getting rapturous advanced reviews. Has the theory of everything finally found the spokesman it deserves? I mean, is that where you might be about being the spokesman for the theory that will explain everything?
Yeah, I don't really see it that way. I mean, I really wanted to write this book because I see modern physics as following a 2,000-year-long quest to understand how the universe works. And it's become so technical that people who aren't trained can't really follow the developments. And I think it's something that should be shared. It should be out there. These are incredibly exciting ideas, and anybody who wants to know about them should be able. But I'm a physicist at heart, and doing the research is really the thing that I'm about.
Well, here's what else they say about you in New York Magazine. He's a great communicator, he's charismatic, he's clearly top of the heap intellectually. So the fact that he has gobs of raw physical appeal on top of that, it gives him a really serious mystique. How did you come to wanting to be involved in the answer to one of the fundamental questions of the universe?
Yeah, that question I've thought about now and then, and I think it really goes back, and I think they even mentioned in the article, when I was, I don't know, 13 or 14, having those existential crises that adolescents do, you know, what's it all about, why are we here?
Right.
And it just occurred to me that so many people, much smarter than I, had thought about these questions through the ages and hadn't come up with very much. Yeah. So it was unlikely that I was going to contribute anything to the answers, but I figured maybe I can just understand the questions at a real deep level, and that'll be the closest that I can come to try to be comfortable with it.